Okay, since I last recorded a little video on how to use Google Sheets, Google, of course, without telling me, decided to go ahead and change how they use it, and they have this nasty little habit where they don't really tell anybody. So one of the things I'm going to do here is to say, hey, this is 2017 of August. Here's the latest, greatest updated version on how to graph on Google Sheets. Also going to toss in a little thing on how to graph on something called Graphical Analysis. Either one you use, I don't really care. I think they're both great. So I've opened up a Google Sheets. Really easy idea. You just click up here and you can type in whatever name you want. I just called this new Google Sheets. And I just came up with some data, really important for my students at least, to always have both the label and the units of whatever the measurements are, or else it is wrong. So volume in milliliters, mass in grams. Something else to know with most sheet programs is that Excel and Google Sheets, whatever's in the first column will be on the x-axis. Let's call that the independent variable. The second column will always be the y-axis. That's the dependent variable. Think of the actor Johnny Depp. Johnny ends in Y. The Y looks like it's kind of an arrow going up and down, sort of, if you use your imagination. And Depp kind of sounds like dependent. Okay, so that's one way to do that. So first thing you want to do is just simply highlight all of the data, including the headers. Second, go up to insert. You would think you'd want to insert a graph, but instead, let's make this really confusing and call it a chart. Now, it's a little different in that this information should pop up. Hopefully, there it is. Pops up on the side. Now, this is not the chart that we want. In science, 99.9% of the time, we are most concerned with XY scatter. And the reason we're concerned with XY scatter is because we're looking at changes. So not bar graphs, not pie graphs. We're looking for patterns, relationships, and changes. So we need to change this. So what I'm going to do is go over here to column chart. We don't want line graph. That would make too much sense. Look. Hey, there's XY scatter right there. Bingo. That's the one we want. And this is looking pretty good. And it does a lot of nice things for us. We have a title. We have units and labels on both sides here. You can see that things are spaced out pretty good. We have a legend, pretty nice. So now we need to customize because we want to squeeze every bit of information we can from this. The chart style is looking pretty good there. Chart axis and titles. The only thing I would change here is on the title. I typically put whatever I'm graphing, so the volume and mass of something. So I'm just going to call it a substance. But again, if you were doing this with like water or copper, aluminum, plastic, whatever, it's nice to kind of put that up there. So here's the other part that is where it's really hidden in series. This is the one. This is the one that's sort of like our money maker here. What we want in this one is this. We don't want error bars or data labels. The trend line is what we want. Click on trend line. You want to do that, and you now have a choice, and it'll try to fit the best line to the data. And from what we can tell, the computer thinks it's a line, and I would probably say, yeah, that's a good line. But nice thing is you can pick a lot of other items here, and we won't always have a line. It might be like if we're doing half-life, it's like exponential, things like that. Don't care too much about the color, but the other thing that we want is here where it says label. There's a drop down. You definitely want to include the equation, and you definitely want to include the R squared value, which is going to tell us how well that equation fits the line. And the closer it is to one, the better. Now, the only thing I haven't figured out, which some people criticize about this, which is worth noting, and I totally agree, is how do you have it go through 0, 0? In this case, we could actually add that as a point. But how do you include that with the trend line? I'm not 100% sure on that one. I would say in this one, we know that 0 mass is 0 volume. That would be, we could definitely put that in there if we wanted to. So this is pretty good. So we have title, mass, and all this stuff right here. We've got the volume, the labels, the units, the equation line, R squared value. That's as good as you can get. Now, what I like to do to clean this up just a little bit is, let's do this. I'm going to go to horizontal axis and the vertical axis. I kind of want to see the 0, 0 and maybe have this extended a little bit more because usually in science, one of the things that happens is we want to see a little bit above and beyond what's already there. And the reason is, so instead of like 7, let's go to maybe 8, because we want to extrapolate and get some idea of where this will go. So there's the horizontal axis and there's the vertical axis, and we can do the same thing here. So the minimum value is going to be 0. And instead of 15, let's go to maybe 18. And if I were to look at this, and that is completely wrong. Okay, so that's, let's see, boy, 18. There we go. Much better. There we go. I hit the wrong button. Happens when we're live. So, and this is a really nice graph now. Title, I mean, it takes up the whole page. If I print this, I definitely want to print the graph. I want to print the data with it, and I want to make sure I take up the whole paper. And that looks fantastic. Now, if you don't want to do this, there's another thing that's really nice and clever called Graphical Analysis. You're probably going to have to download this if you go to the Sycamore Chrome web store. This is a free download. And if we go to here, Graphical Analysis, you can get this on your Chromebooks. And I think even if you don't have a Chromebook, it's free. But you want this to load. The nice thing about Graphical Analysis is it does a lot of the work for you. You can put in manual data. You can put a probe right into your computer, like a temperature probe, which we'll use, and it starts to record it automatically. And life is kind of good. It takes a bit of while to load. I'm just going to do a little bit because I'm not sure how much time I have left here, and I don't want to take up all your time, but I think you'll see how easy this goes. Like I says, it does take a bit of time to load here, but we'll get this up and running. And the nice thing about this, it really already knows that you want to do probably an XY scatter. This is probably a new version of it, and I apologize for the time that takes for this. We may run out of time, but you'll see you can definitely do manual entry. It's very simple, very easy. It's just a matter of knowing where to click and which buttons to push. So we're almost there. And the other thing I'll say too is it's really, really important to understand not only how to make a proper graph, but also how to squeeze as much as you can out of that data. That equation is like gold if we're trying to extend things. The R-squared value gives us some idea of just how good our data is. Is it worth doing the experiment over, or can we trust the data? That R-squared, the closer it is to the number 1, the better. If you have an R-squared of 0.5, that probably means it looks like maybe you sneezed on the graph or something. You got bad data, and I've gotten data that bad before. So this takes almost forever to load. Don't know if it's going to load. There it is. Yes, we're finally loading. Okay, so let's hopefully go through. I definitely want to do manual entry. Click on that, and it's going really slow today, and I apologize. Probably should have preloaded this. I'm only going to do a few of these. Now, the nice thing is column options. You can see here, hey, check this out. For the X, I can go ahead and put volume, and it's not going to let me do anything else until I put in the units as well, which I really, really like. We have a couple of choices, which I'm not going to do here. I can do the same thing with the Y. We'll do mass in grams. Mass in grams. Okay, got that. Let's hit apply there. I'm only going to do like a few pieces of data, but watch what happens when I do the data. It will actually do it as we are speaking. It starts to make the graph. And I'm only going to do 3 data points because we're kind of running out of time here. But you get the idea. Okay. Hey, check this out. Next thing I can do is I can go around. I can definitely change the title if I click up here, or actually if I go down here, excuse me. Graph tools, apply curve fit, same as before. We think it's linear. You hit apply, and lo and behold, there's all the data. So here's the R-squared. They're saying it's linear. It's y equals mx plus b. That gives you the slope, gives you what b is, gives you the best fit. Life is good. Let's say I'm trying to find the 0, 0. Edit graph options. Again, I can move this down. We don't want negative numbers. And I can do this down. That goes to 0. Maybe make this go up a little bit. Super nice, super simple. Mass and volume because we're running out of time. And I can go ahead and add this. And then the nice thing is when you save this, it should automatically save. You can even add annotations. But the other thing you can do too is to, if I go here and hit save, save as and do it as a ping and upload it anywhere. So it's very nice, very handy. And these are the things that we need when we need a graph. Thank you very much for listening. I hope you find this useful. And if you're one of my students, you may want to go to ChemCast because it'll make your life a little bit easier. All the videos will be right there.